All right, we're back. We're playing with our pictures. We're doing PictureLab. In our last video, we kind of launched the Picture Explorer, then kind of showed how it's just a 2D array of pixels. I'm going to pick up there with Picture Explorer once again. I just wanted to show you quickly that you could change the picture that is being used by simply going to the main method where we create the picture object and just changing which image it's using. I included a bunch with your downloads. We got bush.jpg, clinton.jpg, Franklin, etc. Okay, in previous years, I had those in a separate folder. In practice, that's what I would do, is I would have an image folder where these things go, but that changes the file path and it just overcomplicates it for students. So they're all here, but anything ending with a JPEG is one of those president's images. We actually do have some GIFs, the left arrow and right arrow. Those actually get used in the Picture Explorer. I'll show you those, but let's change maybe, let's switch to Franklin. Right. I'm going to change the picture to franklin.jpg, and we're going to execute our Picture Explorer. You can right-click in free space if you don't have the play button available, but that is going to launch our Franklin image. Again, one of the ones that I have provided for you. This left and right arrow, that's the GIFs, right? This isn't something that Java made by default, right? It's not actually included. They're included for us. We could, in theory, explore those maybe, provided that the picture code works for that. Okay, we're going to pick it up there with some of the activities that the College Board is looking for us to do. One of those being taking a look at the ZeroBlue method, right? The following code is a ZeroBlue method found in the picture class. So why don't we go find that first? There's lots of classes over here. We're talking about picture. Okay, that is actually different from Picture Explorer. In fact, I'm going to stop my Picture Explorer, which will close out the picture window. So here is the bottom of Picture Explorer. You can see I still left the variable name beach. It's not a beach anymore. It is possible that this path maybe doesn't look right. I could be wrong. But let's go ahead and try to launch Picture, right? Right now, IntelliJ is trying to work with Picture Explorer, but we actually have multiple classes with main methods in our folder here, which means we need to tell it to run specifically Picture, not Picture Explorer. If I hit this play button again, it's stuck on Picture Explorer, right? So I recommend right-clicking in free space and telling it to specifically run picture.main. All right, yeah. So there was an error trying to open Washington.jpg. This looks like I did not update this correctly. Put an SRC in front of that. Tell it to stop. And you should be able to run picture, right? Look at my IntelliJ. It's now on picture, so I can hit play without having to right-click in free space and tell it to specifically run that. And there we go. There's our path. And we actually got a second copy. What's going on here? Well, we're directing the picture object to the path. We then tell it to explore. Explore is the same method that Picture Explorer was calling. Okay, so that's going to open up a copy. Then we take it and do ZeroBlue. That's the method that we're about to look at. And we tell it to explore again. So this double call to the explore method is why we have two instances of the picture open. We see the original, we see the change. That was done on purpose, so you could see that. That being said, if you don't want to get two copies every time, I'm going to hit this stop button, by the way, which will close out these two windows. If you don't want to get the double copies each time, you can just comment out this line. Right? That we don't really need to see the original. We got a pretty good idea what the original is, but take a look at this ZeroBlue method. There's probably a way to jump to this code. I don't know. I'm going to scroll up and find our ZeroBlue method. It is somewhere around line 89. ZeroBlue. What are we doing? We're going to do this.getPixels2D. Don't worry too much about it. This is definitely a good focus. We are creating a pixel 2D array called pixels. Okay. and we're pulling them out. This is like a graphics thing. So all you really need to know, I wouldn't worry too much about this right-hand side, but you can kind of figure out that it is producing a 2D array of pixels. Why? Because the left-hand side, right? Look at the data type. The data type is a pixel 2D array. So pixels will be a 2D array of pixels. And then we see, what's going on here? This is a for each loop, which gives us a good spot to kind of pause and talk about what's going on there. I was not ready for it this early. All right, here we go. Let's talk about for each loops with 2D arrays. Just like whenever we started doing more and more for each loops, whenever we got to objects, same thing kind of applies here. They make a little bit more sense to me, I think, whenever you're working with objects. In this case, we're working with a pixel object. So it is possible to nest for each loops in order to traverse 2D arrays. We did say we need nested loops in order to traverse them. That is true, but we didn't say they have to be for loops. You could use while loops if you're a madman, but for each loops make a little bit more sense. And I would be prepared to know this. You're going to have test questions involving for each loops in 2D arrays. The key to implementing these loops is understanding that the outer array consists of arrays, while each inner array consists of single elements. Let me maybe go back and pull up the graphic from our previous slides. Right, when we first started talking about 2D arrays, I showed you a couple of tables that kind of helped visualize it. Right, this is actually the most accurate representation of what a 2D array in Java is. We see the outer array, and each element of that is an array. Right, if you kind of tilt it like this, you start to see the grid nature of a 2D array come together. In practice, you can just think about it as a literal grid. Okay, so as it says here, the key to implementing these loops is understanding that the outer array consists of arrays, while each inner array consists of single elements. Here we go. We have nums. It is an int 2D array. This says for each integer array, which we will refer to as row in nums. So nums is the outer array. It has a length of 4. We're going to loop through it. Each element of nums is an integer array. Right? If this is nums, this outer array is nums, each element is an integer array. So we're saying for each integer array, which we'll refer to as row, in nums. Okay? This inner loop, take a look what we're actually looping through. We're looping through row. Row just got created here. Row is an integer array. Each individual element is an int. Okay, so using nested loops, we can loop through nums, a 2D array, to get the element. Okay, so note that the outer loop traverses the outer array. Since the outer array consists of int array objects, each element is an integer array. Nums consist of integer array objects. The inner loop will access each element in the inner arrays, one row at a time. In this case, each element is an int. Note that the inner loop is traversing row, which was defined up here. The advantages and disadvantages of using for each loops remain intact. There's an advantage. Compared to for loops, our for each loops provide simpler syntax, which increases readability. It is very clean, although I'm a pretty big fan of the row column thing. Disadvantages. For each loops cannot be used to modify arrays consisting of primitive data types or immutable objects, such as string. Let me show you an example here. We have a string 2D array called words. Words is an array that consist of string arrays. So I will say for each string array, which we'll refer to as row, in words. I'm then going to loop through the row. Each individual element in row is a single string. So I'll say for each string, we'll refer to as word in row. This is relatively clean. But what we're trying to do here is we're saying that word is equal to ABC. This will change word, but for the iteration. All we're doing is changing this local variable. What we're not doing is changing words. Right? In order to actually change words, you're going to need to refer to an index. You'll need to take words, the literal 2D array, and do a row column index in order to actually change it. Right? The kind of catch to this and where you're going to have troubles, you're going to get exam preps, you're going to get test preps, you're going to miss questions, is when you have methods that can modify themselves. Here, what I'm trying to do is play with a pointer, right? But a mutator method is different. You can have an object mutate itself using its own mutator method. What you can't do is kind of modify the contents of an array or a 2D array just by changing a pointer. That's not going to get you there. We'll practice. Disadvantage. For each loops cannot be used to traverse a 2D array in column major order. Not a big deal for me. I prefer row major order anyway, and row major order is ultimately kind of superior, but you can't do column major because keep in mind, the way that we ultimately did column major is that we kind of flip the order, right? You can't flip the order on these because this is being created by this. Okay, lastly, for each loops can be used in combination with for each loops to traverse a 2D array. You won't see this on the AP exam. I don't think I'll do it on the test or any type of quiz question, but it is possible. Here I'm using a combination of for each and for loop. We're looping through nums. Nums is the 2D array. It is an array consisting of integer arrays. So each integer array we'll refer to as row. So we're saying for each integer array, which we'll call row, in nums. I'm then, keep in mind what we were doing before with our for each loop, right? We were looping through the row. I'm going to loop through the row again with just a standard for loop. What's actually kind of cheeky and clever about this is that we get the clean syntax of a for each loop here, and then this is pretty clean as well. We have an index. You could actually modify nums by doing this. Okay. You could do this. We got a for loop where we're looping through the outer array. I'm then pulling out the element at nums at I. Nums at I, keep in mind nums is the 2D array. So nums at I is a single one-dimensional array, an array of integers. So we're using a for each loop in order to go through that. This one has like none of the advantages, right? We get, I wouldn't even argue that, is this syntax cleaner? And then here, notice that we don't have an index. And so we get like the disadvantages of using for each loops and not really the advantages. I'm just showing that you can do this. I wouldn't. Okay, so we can use for each loops. And that's what they're actually doing here, right? Pixels is a 2D array. What that means is that the outer array, pixels, consists of pixel arrays. Each element in pixels is a one-dimensional pixel array. We'll call that row array. I'm actually going to do us a favor here. Let's call this thing row. Okay. We're then going to loop through row. Each individual element in row is a single pixel. I promise you, you want to make these changes that I'm making. Right? Pixels, the outer array, is a 2D array. Each individual element in pixels is an entire pixel array. So I'm saying for each pixel array, which we'll refer to as row, in pixels. I'm then going to loop through that row. Well, the individual elements are pixels. So for each pixel, which we'll refer to as pixel in our row, we're going to take that pixel and we're going to set blue 0. Without me even going and finding this method, you can guess what it does, right? Keep in mind that our pixels are going to have 3 values, an R, a G, and a B. So we're taking that B value, setting it to 0, and leaving the other 2 alone. Okay? And this idea is the crux of this entire lab, this entire project. An image is just a 2D array of pixels. So if we go through every pixel using for each loops, or just loops in general, we can take the pixels with each iteration and we can modify them. In this case, set them to 0. So I'm once again going to run this, and we see that 0 blue, what does it do? It zeroes out the blue. So there's no blue in the pixels, but the red and green remain intact. That's how we got this. Okay, so with that in mind, what do they want us to do? Using 0 blue as a starting point, write the method keepOnlyBlue that will keep only the blue values. That is, it will set the red and green values to 0. Create a class static method to test this new method, blah, 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 blah. Be sure to call the new method in picture tester. We're just going to create the method here in picture, and we'll call it in the main method below. Okay, I made these changes for good reason, because Mama didn't raise a fool. I'm going to copy and paste this bad boy. I don't know what happened with the indentation, but I'm going to copy this. I'm going to paste it underneath. They want us to make the method keepOnlyBlue. By the way, this is probably a good spot to pause and see if you can actually figure it out yourself. The same concept is going to remain intact. We're going to loop through our pixels. With each iteration, I want to take the current pixel, and I'm going to leave the blue alone. I actually want to keep it as it is. What I'm going to do instead is take the pixel, and I'm going to pause here and kind of see that you can, these are all the things that a pixel can do. Right? We can get alpha, average. Alpha, by the way, is like a transparency. How transparent is it? Get col, which should be maybe our column. Get color. That is the color in its entirety. That is all of it, red, green, blue. Get red, get row, etc. Okay. Set alpha, set blue. Here's what we're looking for. Let's set our green to 0. Right? If we're going to keep only blue, I'm going to set red, and I'm going to set green to 0. So set red, set green. I did this because RGB, all right? This is what everyone's doing, right? You edit the red first before the green. There's no actual difference there, by the way. So I'm going to loop through all of the pixels with each iteration. I'm going to take the current pixel, set the red to 0, set the green to 0. Okay. Let's test this out. Notice this is gray. I'm not actually calling it. We're going to go down to our main method. And instead of doing 0 blue, what I'm going to do is take our image, which is called beach. Of course, this picture of Washington is called beach. We'll take beach and we'll do keepOnlyBlue. Right? I commented this one out because I don't want to see the 0 blue right now. We'll keepOnlyBlue and then explore. I'm going to tell it to run, and we'll see our result. Whoa. Quick question. What would our image look like if we did 0 blue, then keepOnlyBlue? Okay. So these aren't, I mean, these are exclusive. They work by themselves. So I'm going to do 0 blue, then do keepOnlyBlue. Well, by the time we get to keepOnlyBlue, there is no blue, right? It's all 0. So everything is 0 by the time we actually explore it. Just kind of an interesting idea. All right, I'm going to take this guy back out. And what if, let's play with like a different picture. Let's get Obama in here. Very menacing. There is a trump, I believe. Okay, so we can just very easily change out the picture that we're working with. We can also very easily change out the method that we're working with and see the differences. All right, next method. What do they got going on? Negate. Oh, I really like this one. Negate all of the pixels in a picture. To negate a picture, set the red value to 255 minus the current red value. The green value to 255 minus the current green value. The blue value to 255 minus the current blue. And then we're going to test it. All right. So it doesn't matter where we put it, by the way, but I'm going to copy and paste. So let's copy and paste our keepOnlyBlue method or ZeroBlue or whatever. But the method we're creating is called negate. We should probably update some of the Java doc, by the way. Method to set the blue to 0. How about red and green? Method to negate a picture. To negate a picture, set red to 255 minus current red value. Set green to 255 minus current green value. And lastly, set blue to 255 minus current blue value. Okay, same concept. We're going to pull our pixels out into a local parameter. We're going to use our for each loops to go through that. What I would need to do is kind of maybe update my red, green, and blue. I kind of recommend creating variables. Right? Keep in mind, RGB values, they're numbers. They're integers. So I'm going to create an int called red. And that's going to be 255 minus my current red value. Okay, how do I get my current red value? Well, I'm going to take the pixel, and I'm going to get red. Green, 255 minus pixel dot get green. And lastly, blue is going to be 255 minus pixel dot get blue. All right, so I've got the values. These are the new values, right? What's stored in red, green, and blue are the new values. I need to update my pixel. So pixel, we could go through and do like set red. Why don't we do that to red? Pixel dot set green to our green value. This is easy enough, but I will show you an alternate route. Set blue to blue. Okay, we've made the method. Notice it's still gray. We need to call it. I'm going to hop down to my main method here. Let's comment out our keepOnlyBlue and instead do a beach.negate. We're still on picture, so I'll just hit the play button, tell it to run. This should be Trump negated. Oh, I really like this effect. One of my more favorite ones is Franklin. Who is, acquiring electricity, going up into the sky and taking it from Zeus, claiming what is his. Love the negate on this picture. Let's maybe take a look at one more picture, and then we'll move on. I haven't done like Reagan yet. Historically accurate, riding a Velociraptor. Awesome. All right, that's negate. Right? Not too difficult. It's still just working on this concept of looping through the 2D array of pixels. Now, this step here can be kind of condensed, right? We can actually just do pixels.set. Here's our options. Notice that we have color, but it doesn't take in integer values. I kind of wish it did. I kind of wish they would have overloaded this so that you could specify 3 ints, but they did make the one that can take in a color value. So we need a color. Right? We need a new color. And that color, this constructor, does take in 3 values, I believe. Right, so let me show you how I got there. So we did pixel dot, and I saw under our set that we have color available. This takes in a color object as a parameter. So I'm going to make the color object on the spot. Right, I just happen to know. Sorry, there was an import involved there, by the way. Right, it actually imported AWT asterisk. That is where color is at. In this particular case, there are other colors that accomplish the exact same thing out of different packages, but I'm going to do color API Java. Click on this first bad boy, and we see some type of field. There's some predefined colors that exist. But here's our constructor summary, right? I just made a new one. And take a look. We see a constructor here that takes in 3 integers, a red, a green, a blue, in that order. Interesting enough, there's one right underneath it that actually takes in an alpha value. So you could play with like transparent pixels. But getting back to my point, these 3 lines can go, right? We're going to take our pixel and set the color to be a new color based off red, green, and blue, these values that we calculated earlier. I'm going to run it, and you're going to see that we're getting the exact same thing. I'm just showing you that you can kind of condense those lines. Very cool. Let's see what we got next. Write the grayscale method to turn the picture into shades of gray. Set the red, green, and blue values to the average of the current red, green, and blue values. That is, add all 3 values together, divide by 3. I'm going to grab, why don't we do this, and then we'll add our own Java doc. So I'm grabbing my negate method. I'm going to go ahead and Java doc this because what we're going to do is write the grayscale method. Grayscale the picture by replacing each pixel with the average of, how did they phrase it? Turn the picture shades of gray. Set the red, green, and blue to the average. Replace each pixel with the average of the current red, green, and blue values. Okay. Same concept. We're looping through. I've copy and pasted this. Maybe that's a bad habit. But with each iteration, I'm going to figure out the average. Right? I kind of recommend creating some type of variable here, right? Average is going to be equal to the sum of the 3, that is pixel.getRed plus pixel.getGreen plus pixel.getBlue. Right, those are our 3. I want to add them together. I want to divide by 3. I hope you got alarm bells going off. For one thing, there's a pixel.getAverage method that I'm ignoring. But more importantly, this is an integer. This is an integer. This is an integer. I'm dividing by 3. We could have some truncation go on. Does it really matter? Are you really going to see a difference of plus or minus 1 RGB value in terms of the pixel? No. probably more importantly, this division has a higher precedence. So we would do this first and then do the addition. So in order to force precedence, I'm going to put parentheses around this. We're going to add those things up, divide by 3. Again, truncation will occur here. It's plus or minus 1 pixel. Ultimately, I believe whenever we go to set this color, right, I'm going to take the pixel, I'm going to set the color. It's going to be a new color. The red value is going to be average. The green value is going to be average, right? I'm replacing every value with the average of the 3. If this were a double, we may get issues. Yeah. Right? It does need to be an integer, right, for these RGB values. I can't have like a fraction of an RGB value. And there's some truncation that's going to occur, but that's okay. And when we're talking about a scale of 0 to 255 plus or minus 1 in a JPEG, you're not going to be able to tell the difference. Okay, so here is our grayscale. Let's test it out. I'm going to comment out my negate. I'm going to bring back in, we haven't seen Kennedy. Right, so I'm going to take Kennedy, and we are going to grayscale. He's smoking a cigarette in his astronaut uniform here. Spacesuit, whatever you want to call it. Anyway, it's grayscaled. We haven't seen this one yet, and maybe I picked a bad one because he's on the moon, which is kind of gray to begin with. So I'm going to explore so that we see the original photo and then the grayscale. Not a great one. Let's get some color up in here. And let's try the Trump one. Again, we'll see the original, we'll grayscale, and then we'll see the grayscale difference. Here's the original image, color is insane, and here's the grayscale. Right? This is like, grayscale is something I've used a lot when working with Photoshop. It's a cool effect. Sometimes you can like do a grayscale copy, lay it over top, and then like erase through so you got some color shining through in certain spots. I didn't realize that it was just like mathematically done this way. Just like, that's so easy, right? Okay. We're going to kind of wrap it up here. I would just like to remind you that you could do combinations of these things and get different effects as a result. Right? In this particular case, I'm going to negate and then grayscale. And so we end up with that. And the order can matter. Let me comment out the original. What if you grayscale first and then negate? So I actually don't know if that one's any different from the reverse order, but I invite you to play with these. I invite you to play with images. I invite you to go get your own images, throw them into the SRC, and play with them. I'll see you in the next one.